Hi, welcome to Directory Conversations, where we chat with our community of AI safety researchers, share their research, collaborate, and inspire others to build safe AI systems. So, my name is Miriam, and along with Judah, I'll be co hosting today's conversation with Professor Peter Vamplew, an AI safety researcher at the Australian Responsible Autonomous Agents Collective, ARAAC. Thanks for joining us today, Professor Vamplew.
Thank you very much for inviting me along here and share.
Okay, yes, good. So before we go into the conversation proper, can you please briefly introduce yourself and tell us about ARAAC and the motivation for ARAAC's research?
Sure. So I'm a professor at Federation University, which is at Ballarat in Australia. For people who know a little bit about Australian geography, we're about an hour or so west of Melbourne in Victoria. ARAAC is a multi-institution research group. We started off as a small group here at Federation University, and over the years, as a few staff have moved elsewhere, we've kept working together. So we've got staff now at Federation, at Deakin University in Geelong, and also at the University of New South Wales. Our initial focus was purely on the technical side of reinforcement learning, particularly looking at problems with multiple objectives. And around about 2017, we started to get concerned about the emerging capacity of AI systems and the potential for adverse outcomes if they weren't correctly aligned with human behaviour. And it dawned on us that the work we were already doing on multi-objective reinforcement learning had potential applications in that area. So we maintained our technical focus, but also trying to take it across into this area of alignment at the same time.
Mm-hmm. Okay, nice. Thank you. And then how would you say that the research at ARAAC is related to AI alignment, like in more detail, if you could go into it?
Sure. So one of the underlying principles of a lot of AI systems, including reinforcement learning, is this economic concept of maximising expected utility. The idea is that if an agent has some idea of what they're trying to achieve and can quantify that in some way, then if you make decisions that maximise the expected future utility that you're going to receive, a reward signal, so your agent, your computer system, surveys the current situation, it makes a decision, it executes that decision, and it receives a reward back based on the outcome. So, if something good happens, you get a positive reward. If something bad happens, like a robot running into a wall, you get a negative reward. And over time, it learns in what situations, which actions are going to produce the best long-term accumulating reward. Now, in a context, let's say playing a game, that can work really well. You've got a clearly defined goal. You want to win the game. So you let the agent play to the end of the game. If it wins, you give it a positive reward. If it loses, you give it a negative reward. And you play millions or billions of games against itself, it will learn what policy, what strategy to follow to actually maximize this. Now, the problem is that most real-world situations aren't like games, not just one thing we care about. So we've got to somehow identify all of the various conflicting factors that are important. And the traditional reinforcement learning, you've got to write a single scalar reward signal that captures all that information. And in practice, that's very difficult to do. It's very hard to balance all those factors correctly. So often the behavior that you get is not exactly what you wanted. Because that's fundamentally what we mean by misalignment. That the agent's behavior is not perfectly correlated with what we actually wanted as a given user. And as soon as that happens, you have the risk of adverse outcomes. The agent, in trying to maximize that reward, will do something that we actually don't want. And so our thinking is that if you define your rewards in a multi-objective sense, and essentially as a vector rather than a scalar value, it's easier to get that trade-off between the different conflicting objectives correct.
All right. Thank you. You touched on something I was going to ask, but I'll still just go ahead. It's focused on one of your research papers, Prof. The paper Multi-Objective Reinforcement Learning, a tool for pluralistic alignment. In that article, you make a case for multi-objective reinforcement learning versus ordinary reinforcement learning. So I have a few questions. There are three questions, but I'll start with the first two and then ask the third one later. What is multi-objective reinforcement learning, MORL, and the problem you're trying to solve with MORL? How is MORL relevant to alignment of large language models? I'll stop there.
So, fundamentally, MRL is reinforcement learning, but with multiple objectives. So, usually you would have, as I said before, a scale of reward. There's one number that defines how good the outcomes of the agent's behavior are. What we do is to break that down into a finer grained specification. And each time step, the agent's receiving a vector of values instead, where each component of that corresponds to a different objective that we care about. So if you were building an autonomous vehicle, you might have one reward associated with reaching your destination. You might have another one associated with following road rules, one for passenger comfort, one for fuel consumption. And you can learn them at the same time as each other. And then potentially you can define different trade-offs between them. So you can do what we call multi-policy learning. So rather than just a single policy that optimizes that one objective, you can learn a whole set of policies which represent different trade-offs between those objectives. And the nice thing there is that then you don't have to define your reward perfectly up front. Once you see what behaviors are possible, you can then select the policy that actually is the behavior that you want. It also gives you flexibility because you could change that. So I might have a policy which my car follows generally when I'm just doing my daily drive to work. If circumstances change, if now one of my children is ill and I want to rush them to the hospital, obviously I care a lot more about time than I do about other factors like fuel consumption and maybe even follow the road rules. And so I can switch to a different policy and follow that instead. And that's not possible with single objective RL because all of those various factors have been collapsed together into that one reward. You can't go in and change it subsequently after you've done your learning. Now, in terms of large language models, we've seen in recent years reinforcement learning has been used quite a lot for trying to refine the behaviors of LLMs after the initial supervised learning has been carried out. So reinforcement learning for human feedback being probably the prime example of that. And so people have tried to tune these language models to better reflect characteristics like being helpful or being friendly or how formal you want the system to be. Again, if you do that at the level of a single objective, you can just say, look, what is the human's preference? Which of these two options do they prefer? Learn a reward model from that and then tune the system based on RLHF. You risk getting undesirable behavior. If the feedback from the human users has always tended to prefer the options that agree with them, you wind up with a very sycophantic large language model, and that can lead to problems we've seen with things like people developing mental illnesses for interaction with the AI and encouraging them that they're always correct, never actually giving them any contradictory information back. So if you do that with a multi-objective form of RLHF instead, we think those sort of risky outcomes, risky behaviors from the AI are less likely to actually develop in the first place.
What are some potential or actual uses of MORL methods for pluralistic alignment in real life situations? So in the article, you talk about like value pluralistic alignment, steerable pluralistic alignment, jury pluralistic alignment, and fully pluralistic alignment. So what are some potential uses in real life situations related to these various alignment situations?
Sure. So those categories come from the original paper that proposed this concept of pluralistic alignment, which broadly is just saying that alignment is not as simple as just caring about one thing. We need our AI systems to be aligned with multiple values or multiple stakeholders. And so they've broken it down to these three forms of pluralistic alignment. So value pluralistic is one that maps really directly onto multi-objective RL. This is where we care about more than one aspect of the behavior of the system. So if you look at some of the tuning people have done on large language models in the past, there's been trade-offs between, say, how helpful the system is versus how harmful the system is. And if you focus on helpfulness, the system always tries to answer the user and always tries to provide the information that they care about. But that might produce harmful behavior. If I ask the system to actually tell me how to make a pipe bomb, a system that's been tuned purely on helpfulness might actually go ahead and do that. Whereas one that's been tuned for harmfulness probably won't in that case. But if it's been over-tuned relative to the avoiding harmful behavior, the balancing points, then choose the one that you think is the optimal trade-off between those two factors. So you can do that with that sort of content-based level, I guess. You can also look in terms of the way the content is being presented to the user. So some users might prefer a really formal interaction with the LLM. Others might want it to be chatty and tell jokes and so on. We might care about how short or long answers are. And so these are various factors that people have tried to tune for RL systems. The second category is steerable pluralistic alignment. And this basically just means flexibility, that the system can adapt to the individual user that it's working with or the situation that user is in at that time. Maybe I've generally said, look, I'm quite happy for my LLM to give me all of the information I want, even if it results in quite a long response. Today, I'm in a different situation. Maybe I'm interacting with it through voice while I'm driving the car or something, so I don't want a long answer, I just want a brief answer. In a steerable system, I can say, look, my preferences have changed. I want to emphasize brevity today over the complete. Again, multi-objective systems are really natural fits for that because they produce a set of policies that we can choose between. Whereas with traditional RL, you've trained it for one particular set of preferences. You can't easily change them at runtime. You need to go off and retrain the system again. And then the last category is jury-pluralistic alignment. Quite a strange name, this one. It's basically caring about the preferences of multiple stakeholders. One of the criticisms that's been made of RLHF as it's normally applied is that you've gathered preferences potentially from a very wide distribution fit, but they're then used to train a single reward model, which is then used as the basis for the RLHF process. What can happen there is that the reward model, it can't possibly represent the preferences of all of the stakeholders in the system because they're really diverse. And then what tends to happen is that the majority view wins out. And so you find that the dominant views within the population, the system tunes to those and it basically ignores the preferences of any minorities within the population, for example. So jury pluralistic alignment tries to represent the preferences of individuals or subgroups within the population and then combine them together in a way that is, in some sense, fair to everyone rather than just following the majority view.
Great, thank you. Are there any relevant works that have been done since the publication of that paper that touches on fully pluralistic alignments? If so, what are some relevant works you
Yeah, I haven't really seen much yet that does the fully pluralistic, which is where we say we care about all of these things, that we want to represent jury pluralism. We represent a diverse population. But within that population, we want to model their preferences down to the level of individual values as well, and potentially we want the whole system to also be steerable. There's certainly been a lot of growth in work using multi-objective approaches to tuning of LLMs over the last couple of years. My Google Scholar and Scholar inbox alerts are sending me stuff almost daily that's talking about multi-objective LLM ARAAC type processes. But mostly what I've seen so far, that's been at the level of value pluralism and steering. I really haven't seen much so far around the jury pluralism side of things. And I'm speculating a bit here, but I think there's two reasons for that. One is that requires a lot more data. If you want to model the preferences of one person, you've only got to poll them. If you want to model the preferences of a really diverse group of stakeholders, you've got to go out and sample a lot more people, and that can be very difficult, time-consuming and expensive. I think there's also an aspect that the demand for this isn't there so much, because right now most AI systems work at the level of there's an individual user, and I want to satisfy their preferences. We're not necessarily applying these LLMs yet at the level of larger populations or larger groups, and there is a range of preferences that we want to hear about. So hopefully that will change over time, but yeah, I've not really seen a lot of work in that area yet.
Mm-hmm. Thank you. So, given these challenges of large data and single users, like you talked about, if potential research was to be done, if there's some researcher out there thinking about doing some study in this area, how would you advise they address some of these challenges, and in what directions would you suggest they look into, and why?
Sure. Okay, so I guess I've already flagged the data issue. One of the big things, we can't really do pluralistic systems until we have these diverse sets of preference data sets. Now, there's been some work done in that area. There was a really nice study called PRISM, about 3 years ago, I think it was now, led by Hannah Rose Kirk, and they essentially identified the problem with existing RLH data sets, that they were not particularly diverse in how they gathered their data. They were very much focused on American, particularly populations, maybe occasional European population, mostly English speaking, probably skewed towards younger male audiences as well. And so obviously, if you train a reward system based on that, you're only representing that particular subgroup population. The other thing they flagged was that even if there was any diversity within the sample group, the data generally wasn't labelled with those sort of demographic information. So even if you wanted to try and create multiple reward models, there wasn't really that metadata available when they could do that. So they did this large project to gather a bigger data set, deliberately set out to make it more diverse than previous data sets had been. And importantly, they flagged every single response was flagged with the demographic information that was associated with it. So if you wanted to carve the data set up and say, I want one reward model for females and one reward model for males, you could do that. If you wanted to break it up by age or by country of origin or whatever sort of characteristics you wanted, that information is in that data set. They also provided support for value pluralism, because rather than just getting a single response that I prefer, out of these two outputs, show me from the LLM, I prefer the first one, they would actually ask them to rank the two relative to each other across a range of different values. So I prefer this one in terms of its truthfulness. I prefer this one in terms of its helpfulness, but I prefer the other one in terms of its brevity, those sort of things. So again, then you could tune for whatever values you care about. So that's a nice starting point, but the authors themselves acknowledged that there was still big limitations with that data set. In my context, working in Australia, there's very little Australian representation within that. I don't think there's anything at all in Australia's First Nations population. So, for our group, this is one of the things we would like to work on over the next couple of years. If we can find funding to support us to do this, is to actually generate a PRISM-like data set specifically for Australia, ensuring we capture all of the relevant subgroups and minorities within our population. So that's on the data side. But then, of course, the second part is the technical side of how do you actually make use of that data to build these reward models and to do the multi-objective RL to fine-tune your LLM. One thing I would say for anyone who wants to work in that area, go back and look at the foundational work in multi-objective RL. What I'm seeing in some of these papers that are coming out is that people are basically reinventing the wheel. They're starting from knowing a lot about RLHF and then making their own assumptions about how to do multi-objective forms of that. Sometimes they're doing this in ways that we already know as the multi-objective RL community. We've found some of these problems and have already addressed them, and they're re-encountering them and either not noticing them or trying to come up with essentially reinventing this whole solution that already exists. So I would suggest to people, make sure you're aware of the relevant background. To push my own work a bit here, we did a paper called A Practical Guide to Multi-Objective Reinforcement Learning back in 2022. It's designed specifically for this process of taking someone who knows a bit about reinforcement learning and getting them up to speed with the issues that arise and the possible solutions that have already been discovered in the multi-objective RL community. So I think that would be a really good starting point for someone coming into this space.
Thank you.
Okay, thank you. Yes, thanks a lot. And again, the question is, where can our viewers go to learn more about ARAAC and the research that you're doing, and are there any upcoming publications planned? Mm-hmm.
So we have a website which is slightly out of date. It's been outdated for a few months, but araac.au. If we go there, we can get our profiles and links to past papers. In terms of upcoming papers, it depends on the peer reviewers, I guess, but we've got a few papers coming out of one of our PhD students around the role that we think apology could play in alignment systems. So agents that can pick up when a human is upset or disappointed in what the agent has been, issue an appropriate apology, and importantly then modify their behaviour so that they don't do that sort of thing again. We're also doing some work specifically on just trying to improve the efficiency and effectiveness of multi-objective RL algorithms. One of the concerns we have is that while there are these theoretical benefits of using multi-objective RL, obviously it doesn't come for free. There are extra problems you have to solve to get these algorithms to work properly. And 99% of the work in reinforcement learning is in single objective algorithms. So that field is rushing ahead, developing new capabilities, and the small number of people looking at multi-objective RL simply can't keep up. So the gap in terms of the efficiency of the algorithms themselves, the quality of the code infrastructure around them is just growing over time. So if you were an actual practitioner trying to build a real-world product at the moment, you might want to use multi-objective methods because of these theoretical benefits to alignment. But if those algorithms are not going to train as effectively, if they're going to take longer, if they're harder to actually implement because there's not existing code base use of, there's a decent chance you're just going to go with the single objective alternative instead, because at least it actually works. And so we think the AI safety community, of course, tends to be a little wary about doing work that increases the capacity of AI systems. Because obviously the more capable they become in general, that actually increases the risk because there's a wider set of abilities available to them. They can actually impact the world in more ways. But I think in our case, improving the capability of multi-objective RL systems is a direct contribution to safety, because until those algorithms become good enough, we're not going to see the industry actually use it. And so that's kind of our main focus, at least this next year or so, is trying to get those algorithms up to a point where they're at least reasonably competitive with zero objective algorithms. Of course, later this year, there's going to be a big Europe's conference in Sydney around. So we're hoping to be represented at that. So if there's any alignment researchers looking into this interview and want to catch up, please reach out to us before Europe. So hopefully we can make time to have a chat while we're there.
Okay. Thanks a lot for the information you have shared, for everything. Thanks a lot for joining us today. And we look forward to talking to you more and your team in the future. Thanks a lot.
Yeah, thank you both very much.
Okay. That's it for today's episode of Directory Conversations. If you are an AI safety researcher and would like to join our community or chat with us on an upcoming episode, contact us at aisafetyresearchdirectory@gmail.com. Bye, until next time.